Welcome to this explainer. I'm absolutely thrilled to have you here today. So let me ask you, when you think of a freshly minted engineering graduate, what immediately comes to mind? A hard hat on a dusty construction site? Or, I don't know, maybe someone writing lines of code in a digital hub? Or just slowly climbing that traditional management ladder? Well, while those are for sure fantastic paths, today we're going to explore some unexpected, highly rewarding, and totally high-demand career paths that are wide open for engineering grads right now. We're talking about roles that leverage your rigorous technical background in ways you probably haven't even considered yet.
Seriously, just take a quick moment and ask yourself this. Is your engineering degree a cage or is it a key? You know, for way too long, there's been this totally outdated, kind of rigid idea that studying engineering just locks you into a very narrow set of traditional, quote-unquote, hard engineering roles. But the actual reality? That rigorous training you went through, all that problem-solving, systems thinking, the complex math, that is actually a master key. It can literally unlock doors across a massive variety of industries that desperately need your exact analytical mindset.
The sheer breadth of this landscape is honestly staggering. Beyond those typical digital and management routes we always hear about, your engineering degree is highly prized in non-engineering career paths. We're talking health, safety, environment, and quality management, renewable energy analysis, sustainability roles, finance, technical education, and even entrepreneurship. It's like a fast playground out there. But just for the sake of time and to really give you some solid, actionable insights, we're going to dive deep into two specific, absolutely booming sectors today where engineers are in massive demand right now.
Okay, so let's get into Section 1, High-Stakes Safety and Quality, the Engineer as Protector. To really grasp the opportunity here, we've got to talk about the scale of the environment. Look at the high-risk sectors operating in Nigeria today: oil and gas, construction, power, manufacturing, mining, chemicals, aviation, maritime operations, and huge infrastructure projects. These aren't just small operations. These are the massive high-stakes engines of the entire economy. And, well, when things go wrong in these sectors, they go catastrophically wrong. That is exactly why the demand for top-tier safety and quality professionals here is absolutely immense. And guess what? Engineers are a perfect fit for this booming sector. Just think about it for a second. You've already spent years studying complex processes, right? Identifying mechanical and chemical hazards, understanding heavy equipment, and mapping out intricate systems. Because you already know exactly how these things are built and how they operate, you are quite literally the ideal candidate to audit and protect them. Your foundation translates seamlessly into roles like safety engineering, quality assurance, process safety, risk management, and incident investigation. You aren't just memorizing safety rules from a manual, you actually understand the underlying physics and mechanics of the hazards. Of course, to make this kind of pivot, you need the right keys to actually unlock the door. And this is where specific occupational health and safety qualifications come into play. Certifications like NEBOSH, which, if you don't know, is a globally recognized health and safety qualification, along with specialized ISO training, they act as formal validation. They signal to employers that you've taken your raw, hard-earned engineering talent and successfully overlaid it with international safety management and compliance standards. But let's be real here, a piece of paper alone just isn't enough. The source material is super clear on this point. The absolute strongest professionals in this field are the ones who combine their shiny new certifications with actual practical discipline and grounded field awareness. It's the pairing of that formal compliance training with your gritty, real-world engineering reality that makes you practically unstoppable in the job market. You've got to know how things actually work out there in the field, not just how they look in a textbook.
Moving right along to Section 2, Powering the Renewable Future, the Engineer as Innovator.
In lots of parts of the world, words like sustainability and green energy can honestly sometimes feel like trendy corporate buzzwords, just tossed around to look good on a brochure. But in Nigeria, it's basically about survival. Thanks to the ongoing power challenges, local businesses aren't out there buying solar panels for PR points. They are actively searching for reliable, affordable energy just to keep the lights on and the machines running. It has completely evolved from a fashionable trend into a massive, practically driven market. And because of this urgent, undeniable need, we are seeing a massive deployment of specific, localized technologies. The solutions driving this boom include widespread solar systems, localized mini-grids, advanced battery storage, gas-to-power solutions, comprehensive energy audits, and large-scale industrial efficiency projects. So this isn't some theoretical, pie-in-the-sky future tech. This is real hardware and infrastructure being deployed on the ground right now, every single day. This incredible green energy boom has practically created an entirely new vocabulary of job titles for engineering graduates. Whether you're targeting individual homes, small to medium enterprises, heavy industries, or even whole off-grid communities, there is a role for you. We're talking about becoming a solar project developer, a mini-grid project officer, a carbon analyst, an energy auditor, an environmental consultant, or a climate project manager. These are incredibly modern, highly respected, and well-compensated titles for grads who are just willing to step outside that traditional box.
And that brings us to Section 3, your next career move, designing local solutions.
So what does it take to make it here? Well, success in these emerging fields requires a very specific combination. It doesn't just come from knowing the math or having the diploma on your wall. It comes from deeply understanding Nigeria's specific energy access realities, and then using your engineering foundation to design practical, localized solutions. Your on-the-ground awareness, your understanding of what local SMEs and communities actually face on a daily basis, honestly, that is your ultimate superpower when going after these roles.
So, we've explored how you can become a vital protector in high-stakes industries, and how you can be an innovator powering the renewable future. Like we said earlier, your engineering degree is not a cage. It's the ultimate key. Nigeria's infrastructure desperately needs practical, well-engineered solutions, whether that's in safety, sustainability, or beyond. The opportunities are out there waiting. So the only question left for you is, which path will you engineer? Thank you so much for joining me in this explainer, and I really hope this sparks some exciting new ideas for your own career journey.
Hey everyone, and welcome to this explainer. So let's just dive right into it. When you hear the word engineer, what instantly pops into your head, right? For most of us, it's probably someone in a hard hat staring at a blueprint on a dusty construction site, or maybe some tech whiz glued to a CAD screen designing microchips. We usually think of an engineering degree as this, super straight, narrow tunnel that leads to a very specific traditional job. But what if we completely flip that assumption on its head? Today, we're unpacking some fascinating data on non-traditional career pathways for engineers. We're going to see how an engineering background isn't just a single track, but actually this incredibly powerful foundation for entirely different, highly impactful industries.
Which brings us to the golden question. Does an engineering degree actually mean you have to be an engineer in the traditional sense? Well, the short answer is absolutely not. No way. Honestly, you should think of your engineering education less as a final destination and more like a base stat in a video game. A core attribute, things like logic, problem solving, systems thinking. And when you take that super robust base stat and combine it with a completely different field, boom, you create what we call a skill multiplier. You basically become this rare, highly sought-after hybrid professional. So today we're going to break down two massive, non-traditional pathways that are absolutely desperate for these skill multipliers.
So let's look at pathway 1, the money and the risk.
All right, let's start with our first major pathway. This one takes us way, way away from the construction site and straight into the corporate boardroom. It brilliantly shows the mindset shift you need. See, the traditional engineering mindset is entirely obsessed with the how. How do we physically build this thing so it actually stands up and works? But when you shift over to technical risk analysis, the whole lens changes. You're no longer the one building it, you're the one evaluating it. You're looking at a massive proposed project and asking the tough questions. Is this actually technically feasible in the real world? Is it commercially viable? Is it even operationally realistic? Basically, you become the ultimate reality check for the people holding the purse strings.
And you might be wondering, who exactly is looking for this kind of reality check? Well, it turns out it's some of the most powerful institutions on the planet. We're talking about major banks, massive insurers, and giant infrastructure funds. Throw in development finance institutions, heavyweight energy investors, and elite corporate finance teams. I mean, these are entities managing billions, sometimes trillions of dollars. But here's the catch. Their core expertise is finance, right? Not the complex physical reality of the actual things they're pouring money into. They literally cannot do it without your technical mind bridging that gap.
And the stakes here, they are astronomically high.
engineers in these roles become just exceptionally valuable because they're brought in to assess massive, super complex investments. Imagine being the one scrutinizing huge oil and gas assets, or figuring out if giant power projects actually make sense. We're talking massive commercial real estate developments, manufacturing plants, sprawling transport infrastructure across countries, even complex technology platforms and cutting-edge renewable energy investments. Think about it. These are absolutely not things a standard accountant can just glance at on a spreadsheet and instantly understand. They desperately need an engineer to get in there and look at the actual bones of the project.
Which leads us to bridging the finance gap.
But okay, here's the catch. You can't just stroll off the mechanical engineering graduation stage and waltz straight into a top-tier infrastructure fund. There's a bridge you have to cross first to get into this incredibly lucrative industry. The absolute crucial point here is that this pathway requires some deliberate upskilling. You've got the technical base down, but now you need the financial vocabulary. To really succeed here, engineering grads need to dive into areas like accounting and economics. You've got to understand valuation and the nitty-gritty of project finance. You'll need to master financial modeling, get a grip on corporate finance, and really understand investment analysis. Now, I know, it sounds like a ton of work, but remember that base stat we talked about? You already know how to master incredibly complex systems. You're just taking that rigorous brain of yours and applying it to a new language, the language of money and risk.
All right, let's move on to Pathway 2, the knowledge transfer.
So we're going to pivot entirely away from the high-stakes world of finance and investment now. We're looking at a direction that's equally vital but completely different. It's all about education, communication, and basically making really complex things deeply understandable to everyday people. Our sources highlighted this incredibly powerful thought, specifically pointing out that Nigeria needs people who can translate complex knowledge into practical learning. And while that's wonderfully grounded in the specific socioeconomic context of Nigeria, honestly, the truth of that statement ripples across the entire globe. Everywhere in the world right now, technology and industry are advancing at warp speed, and it's leaving a massive gap in practical understanding. There is just this desperate need for people who actually understand the hard science, but, and this is key, who also have the empathy and the communication skills to explain it to the rest of us who don't.
So if you're an engineer who happens to have that rare ability to explain things clearly, wow, an entire universe of careers just opens right up to you. You could build a super rewarding career in traditional teaching or maybe hands-on vocational training. You could jump into instructional design or curriculum development, literally shaping how the next generation learns. There's also a massive demand in corporate learning. Think about training a huge company's workforce on brand new technical systems. And of course, there's technical writing and the completely booming field of online education. All of these roles take your deep, specialized technical knowledge and magically turn it into accessible fuel for everyone else.
Let's dive a little deeper into translating complex knowledge. Let's get a bit more granular here for a second, just to really picture what your daily impact might look like. We're talking about very tangible deliverables. In these roles, you are the one writing the critical manuals. You're putting together the standard operating procedures, or SOPs, that quite literally keep a factory running smoothly. You're drafting the safety documents that, let's be real, keep workers alive on the job. You're creating the maintenance guides that stop millions of dollars of machinery from just completely breaking down. You might be writing technical proposals, developing training materials, or creating certification content. And the ultimate goal behind all this paperwork? It isn't just to write down facts. It's to provide practical, locally relevant learning. You're taking these highly abstract engineering concepts and you're making them work for the real people on the ground in your specific region. Which brings us to what I think is a really powerful equation. Engineering plus communication equals real impact. In countries and industries that are just crying out for practical, locally relevant learning materials, an engineering graduate who also possesses strong writing and presentation skills, you are an absolute powerhouse. Period. In these roles, you aren't just building a physical structure out of steel and concrete. You are building the capacity of the workforce itself. You are making a tangible, long-lasting impact on your local economy and your society as a whole.
Bringing it all together, your unconventional career path.
So as we bring this explainer to a close, I think it's time to really rethink the trajectory of your career. We've just explored two distinct, incredibly exciting alternatives to the traditional engineering route. On one hand, we've got Pathway 1, Finance and Risk. This is where you take that amazing analytical mindset of yours, upskill in economics and financial modeling, and suddenly you're advising the world's biggest investors. On the other hand, there's Pathway 2, Teaching and Writing. This is where you take that exact same technical knowledge, upskill in communication and instructional design, and empower an entire workforce by translating the wildly complex into the everyday practical. Both of these paths start with the exact same engineering degree.
But man, the destinations just couldn't be more beautifully diverse.
Which leaves us with just one final thought to ponder today. Your engineering degree, it's given you an absolutely incredible foundation. It's taught you how to think, how to deeply analyze things, and how to solve problems. But that is really just the beginning of the story. The real magic happens when you decide what you're going to combine it with. So looking back at everything we've covered today, I'm going to leave you with this question. How will you multiply your engineering skills to make an impact? Something to think about. Thanks so much for joining me for this explainer. Keep learning, and I will see you next time.
So, you're a fresh engineering graduate in Nigeria. You probably know firsthand just how intensely competitive the job market is out there right now. Honestly, it can easily feel like that hard-earned degree locked you into this one super predictable and incredibly crowded path. Well, welcome to today's explainer, where we are going to completely dismantle that idea. We're drawing on some truly fantastic, grounded insights from Master Sense by Faraday to explore re-engineering your career, non-traditional paths in Nigeria. If you're looking to break out of that traditional box and leverage your skills in ways you never thought possible, you are in the exact right place. We're going to dive into how your rigorous training actually prepares you for so much more than you might realize.
Okay, let's map out our journey today. First, we'll look beyond the hard hat. Then, we'll explore high-demand career alternatives, followed by the entrepreneurship route. After that, we'll discuss choosing your true path. And finally, we'll lay out your transition blueprint. Let's get right into it.
Part 1. Beyond the Hard Hat, Redefining the Nigerian Engineer.
When you hear the word engineer, what instantly pops into your head? For most of us, it's that very narrow, traditional definition. Being out on a construction site, wearing a yellow helmet, and signing off on endless structural drawings. But let's flip that and look at the future definition, because this is where things get genuinely exciting. Think about building digital products, financing massive infrastructure projects, or optimizing incredibly complex supply chain logistics. Why does this make sense? Because the core of your degree, the real value, wasn't just learning about concrete properties or electrical circuits. It was learning how to break down massive, messy problems into solvable, logical steps. That foundational toolkit is exactly what the evolving Nigerian economy desperately needs to solve modern, systems-level problems. The future of this career is all about applying that rock-solid logic to entirely new industries. You've got to start seeing a financial model or a software architecture as just another system waiting to be optimized.
Moving on to Part 2, High-Demand Career Alternatives and Where Engineering Thinking Truly Thrives.
You know, the modern Nigerian economy is absolutely craving your analytical skills for roles you might never have even considered. Think about becoming a data analyst or a product analyst. Dealing with complex, messy data sets or intricate user flows is remarkably similar to running load calculations or designing a circuit. It's all about finding the most efficient path from A to B. Or consider roles like project coordinator or operations associate. Managing shifting timelines and complex supply chains, that requires the exact same structural planning you used in your engineering projects. And of course, specialized roles like health, safety, environment, and quality, or HSEQ officers, and energy analysts rely entirely on a technical brain to ensure things are sustainable and safe. The reality is, the economy doesn't just need people who can build bridges out of steel anymore. It desperately needs professionals who can build bridges out of data, coordinate digital product life cycles, and analyze sustainable systems. If you can combine your technical brain with a bit of business awareness and clear communication, you become incredibly valuable across all these high-demand sectors.
All right, Part 3, the entrepreneurship route, solving unresolved problems.
Striking out on your own is a massive opportunity here, mainly because Nigeria has these huge, unresolved problems waiting for practical minds to fix them. We're talking about spaces totally ripe for innovation.
agritech and edtech, logistics and waste management, solar maintenance, software, and automation. But listen closely here. Technical brilliance in these areas is absolutely not enough to survive. You could design a flawless, fully automated irrigation system for a commercial farm, but to be a successful founder, you have to surround that core technical solution with essential business skills. You need pricing and finance to ensure that irrigation system is actually profitable. You need sales and marketing just to reach the farmers who actually need it. You have to understand local regulations, tax compliance, and most importantly, your end customer. Why? Because the absolute best engineering businesses aren't built around what a founder can design in a vacuum. They're built around problems people are actually willing to pay to have solved. Without understanding procurement, partnerships, or cash flow, the business simply won't survive the realities of the market.
Which brings us to part 4, choosing your true path and finding your perfect fit.
So, with all these massive opportunities sitting right in front of you, whether in corporate roles or entrepreneurship, how do you actually pick the one that's right for you? Well, you have to stop and ask yourself the most crucial question of all. Where does your personal strength meet market demand? It is so incredibly tempting to just blindly follow whatever the fleeting trend of the day is, right? Today it's the tech sector, tomorrow it's renewable energy, next year everyone will be screaming at you to jump into AI. But the absolute worst thing you can do is chase a trend without looking inward first. You need to pause and find that exact sweet spot between what you naturally excel at and what the market is actually paying money for right now.
To find that sweet spot, you've got to conduct a really honest self-audit. Let's walk through what that looks like. Start by asking, what problems do I actually enjoy solving on a daily basis, even when no one is forcing me to? Then, look outward at the Nigerian landscape. Which sectors are visibly growing, actively hiring, and getting funding? Take a strict inventory of the skills you already have in your toolkit, and be super realistic about what you can learn in the next 6 to 12 months to get competitive. Be honest about your working style too. Do you thrive when you're buried in data, or managing people, tinkering with machines, analyzing money, optimizing systems, or brainstorming big ideas? And finally, you must identify your bridge role. A bridge role is a highly accessible nearby position that serves as a practical stepping stone from where you are right now to the completely new future you want. Figuring all of this out takes your career transition from a blind guess to a highly calculated strategy.
And finally, part 5, your transition blueprint, the practical steps to pivot.
This preparation phase requires you to be intensely specific. Step 1, choose a clear destination. Waving your hands around and saying, well, I want to leave engineering, yeah, that's a wish, not a plan. You need to confidently declare, I want to become a product analyst, or I want to be an energy analyst. Once you've locked in that target, step 2 is to study real local job postings in Nigeria. Pay close attention to the exact software, the specific certifications, and the behaviors employers repeatedly ask for. That gap between what they want and what you currently have, that reveals exactly what you need to do next. Step 3 is meticulously closing that gap. Take strategic short courses, use your NYSC placement for something that actually aligns with your goal, or take on volunteer work just to build a solid baseline of experience.
Then, you move straight from preparation into action by building undeniable proof of your capabilities. Employers need to see what you can actually do. So build a data dashboard, draft a comprehensive business safety plan, code a small app, or conduct an energy audit yourself. Then, step 2. You absolutely must rewrite your CV. Stop just listing traditional engineering tasks. For example, instead of saying you supervised site construction, reframe that. Say you managed cross-functional teams to deliver projects on time and within budget. You have to present your degree as concrete evidence of problem-solving and systems thinking. You've got to speak the language of business. Next, network deliberately by attending industry events and seeking mentorship. And remember step 4. Start close to home with that bridge role we talked about. It leverages part of your old engineering identity to get your foot in the door, while you confidently step into your new one.
As we wrap up this explainer, I want you to burn this core message from Master Sense by Faraday into your memory. Engineering is not just a job title. It is a way of thinking. Do not let the narrowest, most traditional definition of your degree trap you in a corner. That analytical, highly structured way you view the world, it is entirely too valuable to be confined to just one predictable career path. So, I'm going to leave you with this final provocative thought to take with you today. In a country full of complex problems waiting for practical solutions, where will you apply your engineering mindset next? The tools are right there in your hands, the blueprint is right here in this explainer. It's time to re-engineer your own future. Thank you so much for exploring this with me today, and I'll catch you next time.